Hey, Ray, this is Alex Merced from alexmercedcoder.com. And you know what? I'm going to learn another language. So, what we're going to do right now is we're going to learn the ReasonML language. So, as you can see, I still just wrapped up my video on Crystal. But what happens with ReasonML, it's another language that's kind of doing the same thing like TypeScript's doing. I think it came out before TypeScript, but then TypeScript came out and has Microsoft behind it. But essentially, what it's trying to do is create to include typing in a JavaScripty type language, but also include a lot of, but also ReasonML brings in a lot of sort of functional ideas and borrows a lot from the functional programming language OCaml. Okay, actually, literally, you could take OCaml code and it would run just fine in ReasonML code. Um, but you'll see the syntax is still very similar to JavaScript, and it's not a huge leap. So let's see here. So I'm on REPL.it, REPL it, and this is where we can go practice. So right now I have a Crystal REPL up, but I'm gonna get out of that. So I'm gonna go back to my home. I got REPLs for every language. This makes it easy to learn new languages when I have a place where I don't have to like install everything right away. So I'm gonna start a new REPL, and you can see there's a lot of languages you can practice here on REPL. I highly encourage you to take advantage of that. And yeah, maybe I should play some with Java some more. It's been a while. Elixir, I did videos on Dart. Elixir, that might be the one I need. I haven't done Julia yet. We should do Julia in a future video. Crystal, I just did. R, I find R too boring. Swift, I did. I should probably visit F# at some point. Lua, I haven't done yet. JavaScript, I've done the vast majority of my videos on JavaScript. BrainF, it's a fun name. Kotlin, I've done videos on. Haskell might be a fun challenge. Clojure, I've done videos on. I should probably do a video on Scheme. The JavaScript has some lineage there. Ruby, we've done. What am I looking for? Okay, so that reason is down there is the one I'm looking for. So reason here. Okay, reason in a Node.js environment. I see. So we'll just call this ReasonML practice. Let me bring up the ReasonML documentation while that does that. Okay. Now let's take a look. Overview. And we all understand types and stuff. I just want to know the print things. It's just still just console log. Okay. JS.log. Interesting. Okay. Okay, that's always the first thing you want to learn when you learn a programming language. How do I print stuff to the console? Okay. So in JavaScript, it's console.log. But apparently here in ReasonML, it's js.log, which is nice because it's a lot less typing. Although I wish that J was not capitalized, so that way I wouldn't have to do a capital J all the time. Okay, and then as far as declaring variables, that works pretty much the same as JavaScript with let and var and if statements. Again, it's pretty much the same syntax. So let's see here. So let's practice this. Okay, is this open up yet? Here we go. New, well, that's just a JSON thing. I want to open up the source, main.re, js.log. Hello, BuckleScript and Reason. Okay, I think BuckleScript is like a OCaml compiler. That's the reason why it's compatible with OCaml, because BuckleScript can basically translate your ReasonML files and your OCaml files. I've never learned OCaml, at least not yet. We might visit that in a future video, but just so you can understand sort of the close relationship these two languages have. Cool. So first things first, let's talk about assigning variables. So I can do let my var equals 5. There's my variable. Semicolon. I think here they're going to be a little less forgiving regarding semicolons, I'm assuming. And then js.log. You know, and just for my sanity, what I'm going to do is I'm going to do this. I'm going to do log equals js.log. I'm going to actually do this. Const log equals js.log. This way I don't have to type in JS all the time, because I know I'm going to be typing that as a lowercase way too often. Okay, interesting. Do we have constants that way? Let's take a look. Var and let, var and let. Okay, belonging to the script through. So anything about constants? I mean, this is functional, so everything's probably immutable. So I'm assuming basically everything is probably already a constant. Called variable declaration let binds us to names. The let binding transfers is a regular JavaScript variable declaration. For easier debugging. Okay, I'll just use let. I trust you, ReasonML. Okay, let's see if I can do this. Because again, I'm just assuming, because I can do it in JavaScript, that I can do that. So now I can just be like log, going forward, be like log my var. This way I don't have to be typing the extra JS all the time. So run. Does that work? Package operation failed. Well, that's not a good sign. I guess I have to. Oh wait, let's take a look at something. Maybe I need to put my semicolons. Nope. Let's go back to the docs here. Okay. So in that case, I will just do this then. js.log. I will just give in to your ways, ReasonML. My var. Okay, let's run that. Does that work? Package operation failed. Well, let's put that semicolon there. Let's see here. There must be something I'm missing. Let's see here. Reason. Let greeting say hello. So I'm gonna copy this. Let's see if this runs. It's just something I'm completely missing here. Let me double check. Let me see if I can figure out what the deal is, and I'll be right back. Okay, so apparently it's just the REPL.it reason thing is broken. So I'm going to use the one on ReasonML on its GitHub. So you see here it has this kind of cool thing. And what's neat is that you can see it. You can see when you type in reason code, you can see the OCaml equivalent, and you can see the JavaScript equivalent, which is pretty cool. So let's declare that variable again. Let my var equal 5. Okay, so that's how it would look like in JavaScript, and that's what it would look like in OCaml. Now I'm going to see if I can. Now I'm going to try again to reassign that function. So let log equal js.log. Let's see if that works. And then let's log my var. Okay. And then it works. See, it logged my 5 there. Okay, so that's pretty sweet. Okay. Now let's see about conditionals. Okay. Let. I think that pretty much should work the same way. I could consult the documentation, but we'll try it out first. Let my var, as long as it is less than 10, we are true. And if it's true, I want to log my var. Else, I want to log nope. Cool. So let's see here. Why is it not? Oh yeah, it's logging my var. That's right, because it's true. Just logging 5. That's good, and that's how that would look like in OCaml. And this is what it would look like in, I guess, the compiled version of JavaScript that Reason will compile to, because Reason compiles in the JavaScript in the node environment. Cool, cool, cool. Okay. Now, one of the other cool things that's kind of neat is you can create types. That's one of the benefits. So let's say, you know, in my code, I'm going to have, you know, a lot of people with ages, and I just, or let's say a lot of gangs, okay, and I want to denote gang size, okay. So here we go. I can do type gang equals int. Okay, I always forget if it's supposed to be capital int. I think it's just int. Okay. Yeah, a type name must start with a lowercase letter or underscore. So, gang. Okay, and let's see right here. I just saw that a second ago. Type score int, and then here you go. You can type your variables along the way. So I can be like, no, not there. So then I can be like, let the bloods. So we'll have the bloods as a variable, and that's a gang. We'll type it as gang, and we'll say they have 10 members. Okay, and then I can log the bloods. And that should equal 10. That should probably put a semicolon. Is that what it wants? Let's see here. You can, what is it complaining about? This has a type gang defined as int, but somewhere wanted float. Why would it want float? Okay, here's what I'll do instead. I'm just going to change the js.log. There he goes. I have a feeling it's probably a function called log in OCaml somewhere that wanted to do some sort of logarithmic math. Okay, so js.log, that works. It works. So you can do typing. And again, why would that matter? It's about making your code more semantic. Typing, as I've used TypeScript more, I've appreciated typing more, because then I can look at the code and I know what was meant by each part of the code. You know, I know, okay, this is what you want to come back from the function. This is what you want passed into the function. And you can use semantic variable names in JavaScript, but they can only tell you so much. You put a name, or especially when you start passing in like config objects and all these kind of things, typing just helps you be more deliberate, and then also helps you prevent errors, because you get compile errors if you do something not expected, which is nice. Okay, so we know the if works. Let's take a look at some of the other stuff here. String character. I mean, most of this stuff is going to be pretty much the same. I mean, we got tuples, which aren't in JavaScript. Okay, which basically they're just immutable arrays. Okay. Da-da-da. Basically, they are whatever you make them as is what they stay as, and they're denoted with parentheses instead of square brackets. So that's cool. You might be familiar with this already if you do Python. Python has tuples. Okay, let's see here. Other good stuff. List and array. How do they distinguish between a list and array? Okay, lists are homogeneous, immutable, fast at prepending items. Are simple, singly linked lists. Okay, I get that. Okay, so basically it's, well, like in Python, lists are just arrays. But here you usually use lists for its resizability. It's fast and prependent, so that means this is going to be like more of a traditional array. Where's an array? Arrays are like lists, except they are mutable, fast at random access and updates, fixed size on native. Got it. Okay, so basically here they would have a fixed size, while the lists are the more flexible ones. Oh, and you have to surround them with these like bar things. That's interesting. And the reason why that matters is because in other languages, like if you're like using Go or C++, arrays naturally have a sort of fixed size. You kind of say, okay, I want an array of integers of this many spots. And by being that explicit about what you're trying to do, the underlying compiler can then allocate memory, or allocate how your software uses memory much better, because it doesn't have to plan for, hey, what if you want more stuff later? versus when you have something like a JavaScript array, which can pretty much do anything. You have constantly all this sort of memory management that's going on behind the scenes to make sure that there's always accommodation for what you're storing in it. That's one of the things I really like about the Go programming language, is they kind of give you the best of both worlds. You know, when you really just want to when you're fine with like fixed sizes and that memory efficiency, and you want that memory efficiency, you can just use arrays. But when you want something more flexible, you can use slices, which, like JavaScript arrays, are like pointers to arrays. They are not actual. They're not when the variable doesn't actually refer to the data, but refers to where the data is stored in memory. So that's more like this list thing here, okay, which you can do whatever you want with. More like a traditional JavaScript array, which is like a traditional JavaScript array uses the square brackets, or a more sort of standard across programming language array here, where you have to use these lines, the bar and the curly brackets to know, okay, this is a fixed size array. Like I declared this with three items in it, so I can never give it a fourth item. I can change the items, but I cannot add items. I cannot make it bigger. Okay, let's see here. I got a few minutes left, so let's see here. Let's take a look at functions. Okay, functions look exactly the same as we know them from JavaScript. There's our arrow functions. Okay, so if you're familiar with JavaScript, this is pretty much what you've always known. Let's see if there's anything special that I'm seeing. Okay, here's something different. OCaml reason you can attach labels to an argument by prefixing them with label are multi-arguments functions, especially those whose arguments are the same type, can be confusing to call. Use an x, y here, which is y, which is x, which is y. So use x and y here. Since we have curring. I'm not gonna get into curring right now. I've done videos on curring in JavaScript. You guys can watch those. Let's see if there's anything else I want to hit up. And there's no classes here. This is a functional programming language, so there's not going to be any kind of classes, and everything else looks, for the most part, as expected. So there are some extra features. Like here, they're going to get to labeling, which just means you can make more semantic. See, like as you can see here, what they're doing is they're putting a label so that when you look at the description of the code, when you read the code, you have that label there that makes it easier to read what is this supposed to be. But then you can have R and C, which makes it easier to write your function going forward. So that's pretty cool. Curring, which is again breaking up a function into multiple functions. But I'll leave it at that. So this is kind of a quick introduction to ReasonML. Again, it's just a way to have sort of more JavaScript that breaks less. Same sort of role that TypeScript's trying to fill. Just different ways to write your JavaScript with less breaking.